Okay, so now this is question 2 of the midterm. It says, evaluate the following integral. Write your final answer without any trigonometric expressions. Okay, so for this question, we are going to have to use trigonometric substitution. And you can see, if we recognize this, this is technically in the form of x squared, the square root of x squared minus a squared. And we know that this, in trigonometric sub, this would be equal, this would mean that x is equal to a secant theta. So we have to use this for our trigonometric substitution. So first we need to find a. Well, we know that a squared is going to be equal to this and that. So let's go ahead and write. So a squared is equal to 4. And so if we want to find a, we have to square root both sides. That cancels out. And that ends up giving us that a is equal to 2. So we found our a value now. Let's move this to the side. We found our a value. So this means then our x is going to be equal to a secant theta, so 2 secant theta. There we have it. Now we're going to want to write our integral in the terms of this x, which is equal to 2 secant theta. But before we do that, let's also differentiate this expression, because that is also something we don't want to forget. We're going to need that later on. So if we differentiate this, we know that the derivative of 2 secant theta is just 2 tan theta secant theta. 2 tan theta secant theta, and then d theta. Don't forget that. Okay, so now we have everything we need. So let's first start off with rewriting this expression right here, the actual square root. So the x squared minus 4. Let's go ahead and start rewriting that. So if we know that x is equal to 2 secant theta, then we know that we can write 2 secant theta squared minus 4. Okay, so if we then expand this, then this turns into what? This turns into 4 secant squared theta minus 4. And we can then factor out a 4 out of the expression under the root. So we can do 4, and that leaves us with secant squared theta minus 1. And what do we know? Secant squared theta minus 1, that is one of our identities. That equals to tan squared theta. So we can rewrite this then as the square root of 4 tan squared theta. And we then know that if we now square our answer, the square root of 4 is 2, and the square root of tan squared theta is just 10. So we're left with 2 tan theta for that following expression. So let's go back and look at our integral now. Our integral is, remember, x to the power of 4 x squared minus 4 all over 1. So now if we want to rewrite this, it would be x to the power of 4. So x to the power of 4, that would be 2 to the power of 4. 2 to the power of 4 is 16. 16 secant to the power of 4 theta multiplied by our expression, which we found is 2 tan theta. And this is overall, 1 over all this, and then times our dx. What is our dx? Well, our dx is right here. So we can go ahead and we can actually move our dx here, and we can write it on top on where the numerator is. So we can write 2 tan theta secant theta d theta, as so. Now we're going to have to start canceling out things. You can see that we can cancel out that 2 tan theta and the 2 tan theta. That cancels out. Now we're left with this secant theta, and we're left with this 16 secant to the power of 4 theta. So this we can also then cancel out. This leaves us with to the power of 3. So we can then rewrite it as 16 secant cube theta over 1 d theta, just like so. And so we can see that there's a 1 over 16 in this, so we can take the constant out, and that leaves us with just 1 over secant cube theta d theta. Now, what is a basic trigonometric expression or identity that we learn is that 1 over secant is equal to cos. So we can rewrite this now as 1 over 16 and the integral of cos cubed theta d theta. So now all we have to do is evaluate this integral. How can we evaluate this integral? Well, let's first go ahead and copy this. And so the trick with these integrals, these trigonometric integrals, is we want to split it. So we can actually split this into 1 over 16 and then cos squared theta times cos theta. This is, this is still equivalent to cos cubed theta. And we want to do this because now we can use u substitution. So if we let u equal to cos theta, oh my bad, if we let u equal to sine theta, then that means our du is going to be equal to the derivative of sine theta, which is cos theta d theta. And we can see that cos theta d theta is right here, and so that means this is our du. But how about this cos squared theta? Our u is equal to sine theta. Well, we know that this is an identity, and we can rewrite this as sine, 1 minus sine squared theta. And now we have rewritten this in terms of sine, which means that we can rewrite it as 1 minus u squared. And so now we have this simple integral that we have to calculate. Let's rewrite it. So we just have to integrate now 1 over u squared du. And we just have to integrate this. So this is pretty straightforward. This will give us 1 over 16. And then the integral of 1 is just u. And the integral of u squared, that is just going to be equal to u cubed over 3. Now we're not done yet because we still have to undo our u substitution. So this is technically 1 over 16. And then we have sine theta minus sine cubed theta over 3. And we're still not done yet because we actually need to find this theta and this theta. We have to find these because our answer has to be without any sort of trigonometric expressions. So how can we find that? Well, we know that in the beginning, before we even started simplifying all this, we had this expression right here, x equal to 2 secant theta. Well, if we know that x is equal to 2 secant theta, we can find secant theta. And that would just be by dividing that 2, meaning that secant theta is equal to x over 2. And so why is this useful? Well, because we know secant theta, right? Secant theta is the inverse of cos theta. Cos theta, we know from when we learned trig, the ratios, cos theta is the adjacent over hypotenuse. So that means if we were to take the reciprocal, that would technically mean that this x is our hypotenuse and this 2 is our adjacent. And from that, we can now form a triangle to help us find what we actually need, which we know that we have to write this in terms of sine theta. So we would need our opposite. We already have our hypotenuse, but what is our opposite? So let's draw a triangle. And so let's just say that this is our angle theta. And so we know that this would be our opposite. Our adjacent would be right here, and we know that that is equal to 2. And we know our hypotenuse is here, and that is equal to x. So now how can we find our opposite? Well, this is just basic Pythagorean theorem. So let's, we'll leave that variable as O. So that technically means the Pythagorean theorem is O squared as an opposite. So this squared plus this squared. So that's 2 squared. We know 2 squared is 4, so let's write that. And that is equal to our hypotenuse, which is x squared. All we have to do is do some rearranging. So that means we have O squared. That is equal to x squared minus 4. And then we take the square root. And just like that, we have found our opposite. This is what our opposite is equal to. So then, now we know that we have to write it in terms of sine theta. So, sine theta, we know, is equal to opposite over hypotenuse. And so our opposite is equal to this. So let's write that down. X squared minus 4. And it's over the hypotenuse. Our hypotenuse is x. So there we go. Now sine, we also have to find sine cubed theta over 3. Well, we can think of this as 1 over 3 sine cubed theta. And so we can write it as 1 over 3 to the power of 3, just like that. So now let's use these and put it into a final expression. So then, it's equal to 1 over 16, our sine theta, which we know was this, sine theta, and this is then subtracted by sine cubed theta over 3. And so we can go ahead and simplify this a little by actually, the first thing we would actually want to do is that 1 over 16. We can factor out a 1 over x. A 1 over x, and that would leave us with x squared minus 4 minus 1 over 3 3 over 2 x squared. And then we could just factor out that 1 over x overall. Subtracted by x squared minus 4 to the power of 3 over 2 3x squared. And let's not forget the plus c. And so that is what the answer would be for this question.